Passive design is a method of construction where a comfortable interior environment can be created using very little energy, simply by eliminating the reliance on active heating or cooling systems. Passive design works on a specific set of 5 main principles: solar gain, thermal mass, reducing thermal bridges, air tightness, and the MHRV system. If we look at the sketch on the left hand side, we see a dwelling labelled active design. This is a method of construction which has to actively heat the house. If we examine the sketch carefully, we see there are small windows on the south side of the house. This leads to minimum solar gain, which results in minor light and heat gains. If we look at the insulation levels, there is minimum insulation, which means that this house will struggle to retain heat. The house is primarily heated by using a fossil fuel burner, such as an oil burner. This would be expensive to heat and also give off harmful CO2 emissions. This burner is also used to heat the water for the house. Lastly, the house relies on artificial lighting, and hence the light bulb is in the very centre of the sketch. Taking all this into account, this will not be an efficient house. It would be an expensive house to heat, it will rely on artificial light and the burning of fossil fuels. This will ultimately have a harmful effect on the environment. In contrast, if we look at the passive house design, it works to passively supply the house with light and heat. To maximise solar gain, it has large south-facing windows, with the largest facade orientated within 30 degrees of south. It also has a solar panel on the south side of the roof. As we can see, this solar panel is connected to the hot water cylinder. We know this is a solar thermal or evacuated tube solar panel and can heat between 40 to 60% of hot water needs. A PV or photovoltaic solar panel could also be installed on the south side of the roof. This would provide electricity for the house. The house is also super insulated and has maximum amounts of insulation in the floor, wall and roof. To ensure thermal comfort, it is very important that the house has a high thermal mass. Thermal mass is a property that enables building materials to absorb, store and later release significant amounts of heat. Materials such as concrete, which have a high thermal mass, are very important in a passive house, as this helps to moderate temperature fluctuations. If a house has a low thermal mass, it will be prone to overheating, as is highlighted in this sketch. The next aspect which is vitally important to passive house construction is air tightness. Air tightness is the control of airflow within a building. This means there is no unexpected air leakage. Air tightness can be achieved by having an undisturbed air tightness barrier on the internal envelope. There are several methods of creating an air tightness barrier. The approach chosen often depends on the level of air tightness that you are trying to achieve. In passive house construction, where an air tightness level of 0.6 air changes per meter cubed per hour has to be achieved, a surface cavity with an air tightness membrane is a common approach. With the house being so airtight, it is important to use an MHRV. A mechanical heat recovery ventilation system is used to remove the stale air from wet rooms like the kitchen and bathroom, and to bring in a constant supply of warm fresh air. Taking all this information into account, it is clear to see that passive house construction has many positives. A passive house is an extremely efficient building and will benefit the homeowner with regards to thermal comfort, air quality, low energy bills and sustainability. Thanks for watching.